There is an almost mystical feature of JavaScript functions that many developers fail to fully understand. And what I'm talking about is something called closures. So when I ask my students what's the hardest JavaScript concept to understand, then many people say that it's closures. However, I believe that with the right explanation, it's actually not that hard, especially when you already understood everything that you learned before in this course, such as execution contexts, the call stack, and the scope chain. Because closures kind of bring all of these concepts together in a beautiful, almost magical way. So enough talk, let's see what closures are all about. So I'm going to start by creating a new function here called secure booking. And it is this function that will create the closure. Now, the first thing that I need to tell you about closures is that a closure is not a feature that we explicitly use. So we don't create closures manually like we create a new array or a new function. So a closure simply happens automatically in certain situations. We just need to recognize those situations. And so that's what we're going to do here in this example. So we will create one of those situations so that we can then take a look at a closure. So anyway, let's now continue writing this example. And I'm calling this one passenger count. And it will start at 0, but we will be able to manipulate it. And I'm calling this function here secure booking because this passenger count variable cannot be manipulated and accessed from the outside. So, and now what's special about this function is that it will return a new function. And what we do in this function is to update the passenger count variable. So the variable that is defined in the parent function. So that's important. And then let's just log the new passenger count to the console. So passenger count. All right. And now let's call the secure booking function and then store the result in a variable called booker. And so this is actually pretty similar to what we did previously in the lecture of functions returning other functions. So we have one function here that we call, and this function will return this new function. And so as we call secure booking, it will return exactly this function, and it will then be stored inside this booker. And so this here is going to be now a function as well, right? So let's analyze in detail what happens when this line of code here is executed using all the concepts that we already know about. So this is exactly the code that we just wrote. Now, before we start running the secure booking function down here, our code is running in the global execution context. And in there, we currently only have this secure booking function. And so we can also say that the global scope now contains secure booking. Then, when secure booking is actually executed, a new execution context is put on top of the execution stack. Now, remember, each execution context has a variable environment, which contains all its local variables. In this case, it only contains the passenger count set to 0. This variable environment is also the scope of this function. And so the scope chain of this execution context looks like this. So passenger count is in the local scope, but of course, this scope also gets access to all variables of the parent scopes. And in this case, just a global scope. Anyway, in the next line of the secure booking function, a new function is returned and it will be stored in the booker variable. So the global context now also contains the booker variable. And now what else happens when the secure booking function returns? Well, that's right, its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. It really is gone now. And that's important to be aware of and to keep in mind. And for now, that's actually all we did. So all this is nothing new at this point, right? All we did was to analyze the call stack and the scope chain as we call the secure booking function. And this is going to be important to later on understand the closure. So as of yet, we didn't see the closure yet. All we did was use the knowledge that we already have to understand how this Booker function was created, because that's going to be important for the next step. So let's now go back to our code to actually use the Booker function and then finally see the closure in action. So now that we understand how the Booker function was created, let's now actually call it here. So calling it a couple of times here. And as we can see, it doesn't need any arguments. There's no list of parameters, right? So let's call it here 3 times. And now let's reload the page here. And indeed, we get 1, 2, 3 passengers. And so what this means is that the Booker function was in fact able to increment the passenger count to 1, then to 2, and then to 3. But now, if we think about this, then how is this even possible? How can the Booker function update this passenger count variable that's defined in the secure booking function that actually has already finished executing? And so, as I just said, this function has already finished its execution. It is gone. So its execution context is no longer on the stack, as we just saw in the slide. But still, this inner function here, which is the Booker function, is still able to access the passenger count variable that's inside of the Booker function that should no longer exist. And maybe you can guess that what makes this possible is a closure. But before I explain exactly how the closure works, I want you to appreciate once more how strange this actually is. So again, this Booker function here is simply a function that exists out here in the global environment, or in the global scope, right? And the environment in which the function was created, so this here, basically, this environment is no longer active. It is in fact gone. But still, the Booker function somehow continues to have access to the variables that were present at the time that the function was created. And in particular, this passenger count variable here. And so that's exactly what the closure does. So we can say that a closure makes a function remember all the variables that existed at the function's birthplace, essentially, right? So we can imagine the secure booking as being the birthplace of this function, so of the Booker function, essentially. And so this function remembers everything at its birthplace by the time it was created. And this cannot simply be explained with the scope chain alone. So we need to also understand the closure, and so let me now really explain how it actually works. So this is how we left the call stack and the scope chain after the last slide. And the most important thing to notice here is that the execution context of secure booking is no longer on the call stack, because again, this function has finished execution long ago. So now it's time to finally run the Booker function and see exactly what's gonna happen here. And note that Booker is really this function here located in the global scope. Anyway, the first thing that's gonna happen is that a new execution context is created and put on top of the call stack. And the variable environment of this context is empty, simply because there are no variables declared in this function. Now, what about the scope chain? Well, since Booker is in the global context, it's simply a child scope of the global scope, just like this. But maybe now you're starting to see the problem. So how will the Booker function access the passenger count variable? It's nowhere to be found in the scope chain, right? So this is where we start to unveil the secret of the closure. And the secret is basically this. Any function always has access to the variable environment of the execution context in which the function was created. Now, in the case of Booker, this function was created, it was born in the execution context of secure booking, which was popped off the stack previously. Remember? So, therefore, the Booker function will get access to this variable environment, which contains the passenger count variable. And this is how the function will be able to read and manipulate the passenger count variable. And so it's this connection that we call closure. So let's say all that again to make this really clear. So a function always has access to the variable environment of the execution context in which it was created, even after that execution context is gone. And this last part is really important. The closure is then basically this variable environment attached to the function, exactly as it was at the time and place that the function was created. And this probably still sounds confusing, but don't worry, I have some more familiar analogies in the next slide. For now, we are just trying to understand the mechanism behind the closure, so how it all works behind the scenes. So what matters the most here is that the Booker function has access to the passenger count variable because it's basically defined in the scope in which the Booker function was actually created. So in a sense, the scope chain is actually preserved through the closure, even when a scope has already been destroyed, because its execution context is gone. This means that even though the execution context has actually been destroyed, the variable environment somehow keeps living somewhere in the engine. Now, we can say that the Booker function closed over its parent scope, or over its parent variable environment. And this includes all function arguments, even though in this example we don't have any. And now this attached or closed over variable environment stays with the function forever. It will carry it around and be able to use it forever. To make it a bit more digestible, we can also say that thanks to the closure, a function does not lose connection to variables that existed at the function's birthplace. That's a bit more intuitive, right? But anyway, let's see what happens now with execution of the Booker function. So the function attempts to increase the passenger count variable. However, this variable is not in the current scope. And so JavaScript will immediately look into the closure and see if it can find the variable there. And it does this even before looking at the scope chain. For example, if there was a global passenger count variable set to 10, it would still first use the one in the closure. So the closure basically has priority over the scope chain. And so after running this function, the passenger count becomes 1, this message is logged, and then the execution context is popped off the stack. Then execution moves to the next line, we get a new execution context, and the closure is still there, still attached to the function, and the value is still 1. And so now this function executes, increasing the passenger count to 2 and logging a message again. Okay, and that's what closures are and how they work behind the scenes. And I know that this is all quite complex, so let me give you a couple different definitions of closure now, some more formal ones and some more intuitive and maybe easier to grasp. And the most formal definition of closure is the one we already saw, which is that a closure is the closed over variable environment of the execution context in which a function was created, even after that execution context is gone. Or in other words, even after the function to which the execution context belongs has returned. Next, and a bit easier to understand, a closure gives a function access to all the variables of its parent function, so the function in which it is defined, even after that parent function has returned. So the function keeps a reference to its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout time. Alright, another definition, or let's say analogy, is that a closure makes sure that a function does never lose connection to the variables that existed at the function's birthplace. It remembers the variables even after the birthplace is gone. It's like a person who doesn't lose connection to their hometown. In this analogy, the person is the function and the hometown is the function's parent scope, and the function then doesn't lose the connection to the variables stored in this parent scope. And I hope that makes sense. Finally, some people like to think of this attached variable environment as a backpack. So in this analogy, a function has a backpack which it carries around wherever it goes. And this backpack contains all the variables that were present in the environment in which the function was created. Then, whenever a variable can't be found in the function scope, JavaScript will look into the backpack and take the missing variable from there. So kind of similar to the other definitions, but maybe a little bit more visual. So these are some different ways of defining closure, but they all mean the same thing. So they all represent the same idea. Finally, we need to understand that we do not have to create closures manually. And this is also what I already touched on at the beginning of the lecture. So instead, this is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That's because closures are not like a tangible thing. They're not like an object or so that we can access. So we cannot just reach into a closure and take variables from it. That's impossible, because a closure is just an internal property of a function. We can observe that a closure happens, because functions magically keep having access to variables that should no longer exist, but we cannot directly access these variables. However, what we can do is to actually take a look at this internal property, so at this backpack, so to say, in the console. So let's quickly do that before we finish this lecture. And we can do this by using console.dir, and then of the Booker function itself. So similar to console.log, but this one is a bit different. And so here we now get this function itself. So we can get the arguments, the name property that we already took a look at before, and then down here we have this scopes internal property. And this internal scopes property here is basically the variable environment of the Booker function. Now in here, we can actually see the closure coming from secure booking. All right. And so this is where we see the passenger count, which currently stands at 3. And so this closure here basically is the variable environment of this secure booking. So that's the one that is being preserved by the closure. All right. And by the way, whenever you see these double brackets here, that means that it is an internal property which we cannot access from our code. All right. This was a long video about closures. Now, in the next lecture, we're going to take a look at 3 more examples of closures and also analyze how they work, because it's really important that you understand this concept of closures. It's a feature that's used all the time in JavaScript, and many times even without us realizing that closures are happening. So if you want to become confident as a programmer, you always need to know how exactly everything in your code works. And that, of course, includes closures.